Hey guys, this is going to be a quick one because I'm a little bit out of it today and the copier's going, and so hopefully maybe you've seen this before. If not, it's a pretty cool concept that I think you're going to grasp nicely. We are doing section 2.8, graphing two variable inequalities. Awesome. Alright, so this is a linear inequality in two variables. It looks just like a line. The line y equals negative 2x plus 1, where the y-intercept is 1 and the slope is negative 2. We're going to graph it the same way we graph a line, except instead of the solutions being the points on the line, the solutions are going to be all the points on one side or the other of the line. So we're going to graph the line as we normally would. We're going to start at 1, go down 2 over 1, down 2 over 1. And because it's greater than or equal to, our line is going to be a solid line, because we're saying that the points on the line are also solutions to the inequality. And then we have to decide if our answer is going to be all the points on this side of the line or all the points on this side of the line. In order to determine that, we're going to pick a point on one side or the other and see if it comes out true when we plug it into our inequality. The easiest point to pick is always 0, 0, because when you plug in 0, you get really nice numbers. Notice that 0, 0 is to the left of the line we just drew. That means that if 0, 0 makes this inequality true, we're going to shade to this side of the line. If it makes the inequality false, we're going to shade this side of the line. So let's plug in 0, 0. 0 is greater than or equal to negative 2 times 0 plus 1. 0 is greater than or equal to negative 2 times 0 is 0 plus 1 is 1. Is 0 greater than or equal to 1? That's what you have to ask yourself. Hopefully your answer is no, because 0 is not greater than or equal to 1. So since this is not a solution to the inequality, we're going to shade on this side of the line. All the numbers on this side of the line actually make the inequality true. Let's check one just for fun. How about the point 5, 0? So 5 is x and 0 is y. Plug in 0 for y and 5 for x, and see what happens. 0 is greater than or equal to negative 10 plus 1. 0 is greater than or equal to negative 9. That is a true statement. And you'll see that if you pick any point on this side of the line, it will come out to be a true inequality. Let's try another one. This time we just have a less than. It's not less than or equal to, it's just less than. That means we're going to use a dotted line. It's the same exact line we just talked about. We're going to start at 1, down 2 over 1. But this time we're going to use a dotted line, because the points on the line are not solutions to this inequality. So we have to use a dotted line. Again, 0, 0 is to the left of the line, so let's check 0, 0. 0 is less than 1, because negative 2 times 0 is 0. That is a true statement, so this time we're going to shade to the left of the line. That's the only difference between graphing linear equations and linear inequalities, is the shading. Sometimes you shade to the left, sometimes you shade to the right. The way to determine which way to shade is to pick a point and see if it makes the statement true. Alright, I'm going to mix it up a little bit now. Now we're going to talk about absolute value inequalities, which hopefully you already watched the video on transforming absolute values. Basically, you're just shifting it left, right, up, down, changing the slope. Here's an inequality, but it's not solved for y yet, so we have to solve it for y. So I'm going to minus 1 from both sides, so now I have negative y is less than the absolute value of x plus 2 minus 1. But again, I have the negative in front of the y, so I have to divide by negative 1. Remember, when you divide by a negative, this sign flips over. So when I divide this by negative, I get negative absolute value of x plus 2. And when I divide negative 1 by negative 1, I get plus 1. This tells us that our absolute value is going to go from being normal, upright, up 1 over 1 like this, to shifting, reflecting over the x-axis, shifting left 2 and down 1. So our new inequality looks like this. Left 2, down 1, upside down. So here we go. Down 1 over 1. Told you I was out of it today. Left 2, down 1, down 1 over 1, down 1 over 1. And again, because there's no equal sign, this should be a dotted absolute value line. So sometimes in order to make it dotted, if you forget, you just go back and take little pieces out of it with an eraser like this. Now it's dotted. We're going to do the same thing. The solutions are either going to be inside the absolute value or outside the absolute value. So I'm going to check the point 0, 0. You can plug it into any step. I'm going to use the last step just because it's right here. So 0 is greater than, 0 plus 2 is 2. The absolute value of 2 is 2. Negative 2 plus 1 is negative 1. Is 0 greater than negative 1? It sure is. So since 0, 0 is a solution, that means all points outside the absolute value are solutions to this inequality. So it's the same thing you were doing with lines, except you now have a V. Let's try one more. Last one, I swear. Okay. Y plus 3 is less than or equal to the absolute value of x minus 1 plus 2. Solve for y. Oops. Subtract 3 from both sides. So now our inequality moved right 1, down 1. Let's make this graph a little bit bigger. Right 1, down 1. And it still opens up, so and the slope is still 1, so I'm still going to go up 1 over 1. Go ahead, Miss LaVista. Make your little hole punch. Everybody listen. Say hi to Mrs. LaVista. Hi, Mrs. LaVista. Well, this time I can't use the point 0, 0 because the graph goes through the point 0, 0. I have to use a different point on the graph. Pick a point, any point. Again, I like this one. It's pretty. 5, 0. I'm going to plug in 0 for y. Go ahead. She's so cute. She's waiting until I breathe so she can hole punch her papers. You should all thank her for that. She doesn't realize how close my mouth is to this microphone, and that's all you can hear. 5 minus 1 is 4. The absolute value of 4 is 4. 4 minus 1 is 3. Is 0 less than or equal to 3? Hopefully in this lifetime it is. So this point is a true statement. So now we're going to shade outside the absolute value. Now, there are lots of videos on this topic. If you don't like my explanation, go watch one, but make sure you come to class understanding how to graph an inequality and an absolute value inequality. Have a good day!